Hello students, this is Indrani ma'am from Rasayan. In this lecture, I will explain some distinguish between type questions from previous year's board question on this chapter, alcohols, phenols and ethers. First one is distinguish between 1-propanol and 2-methyl-2-propanol. First, draw the structure of 1-propanol. Propanol, propan means 3 carbon atoms. So this is 1-propanol. This is 2-methyl-2-propanol. So what is the difference between these two compounds? Both are alcohol. But here this OH group is attached to primary carbon. So this is 1 degree primary alcohol, and this OH is attached with a carbon which is attached with 3 more carbons. So this is tertiary carbon. So this is tertiary alcohol also. So mainly what we have to do, how to distinguish between primary and tertiary alcohol, that one we have to show. There is one reagent, concentrated hydrochloric acid and anhydrous zinc chloride. It is called Lucas reagent. If you take alcohol, if you treat with concentrated HCl in presence of anhydrous zinc chloride, what will happen? You will get RCl plus you will get water. Alcohols are soluble in Lucas reagent, but this halide is not soluble in this reagent. So if you will get halide from alcohol, then in the reaction medium, in the solution, you will get milkiness or turbidity. So here if you add Lucas reagent, then immediately turbidity appears because this form halide easily. So here you will get turbidity or milkiness by adding Lucas reagent. But here for 1 degree alcohol, it doesn't give any milkiness or turbidity. So you can write no turbidity at room temperature. Next is distinguish between diethyl ether propanol. This is diethyl ether. Ether functional group is there. This is propanol. Alcoholic OH group is there. How to distinguish? Only propanol, when it is treated with metallic sodium, it evolves hydrogen gas and form alkoxide, O minus Na plus hydrogen gas. But for the same reaction here, there is no evolution of hydrogen gas. So no reaction. But if you boil this diethyl ether with HI at high temperature, what will happen? If you heat it, 2 molecules will react to form ethyl iodide or iodoethane. Now if you treat this with silver nitrate solution, what will happen? Precipitation of silver iodide takes place. Next is how to distinguish between phenol and cyclohexanol. This is phenol, this is cyclohexanol. Take phenol, if you treat it with neutral ferric chloride solution, what will happen? You will get this violet complex. So violet coloration takes place, plus HCl plus H plus 6. So here also 6. Now here 3, here 3. But for cyclohexanol, if you treat it with light neutral ferric chloride solution, there is no violet coloration. So there is no reaction or no violet coloration, you can write. Another reaction is there when phenol is treated with bromine water, means aqueous medium, you will get white precipitate of 2,4,6-dibromophenol. plus HBr. This is as white PPT. But with cyclohexanol there is no white PPT, so there is no reaction. Similarly, you can distinguish between these two, and this is benzyl alcohol. So phenol gives violet colored complex with neutral ferric chloride solution, but benzyl alcohol will not give. Similarly, you can distinguish between this secondary alcohol, this is 2-degree alcohol, and phenol by ferric chloride test. Now how to distinguish between 2-pentanol and 3-pentanol? First draw the structure. This is 2-pentanol and here this is 3-pentanol. Now see, with this carbon, 2 carbons are attached, so this is secondary alcohol, this is also secondary alcohol. So by Lucas test we cannot differentiate. Then how to distinguish between them? Now see here, compound having CH3CO group means ketomethyl group, or compound having a group which upon oxidation gives this group gives haloform reaction. Now see here, CH3CH8 secondary alcohol is there, and this upon oxidation will give what? CH3CO group. But this upon oxidation will give CO, but CH3CO moiety is not present here. So you can distinguish them by haloform reaction. Now what we have to do? We have to take NaOH solution iodine. So these two will react to form sodium iodide plus sodium hypoiodide NaOY plus water. Balance this one. Now this sodium hypoiodide will oxidize alcohol first. So here you will get plus NaOY, you will get CH3CO, CH2, CH2, CH3 plus NaI plus water H2O. So now this is ketomethyl group. So it will react with sodium hypoiodide. We will get from this part CH3, CH2, CH2, COONA. Plus from here you will get yellow precipitate of iodoform. But since here no ketomethyl group is there, so with this reagent there is no yellow precipitate, no reaction. So in this video till this, if you like, please subscribe. Thank you for watching.